Assalamu alaikum student. Today we discuss the topic that is the RL series AC circuit. Okay, in RL series circuit we take the resistor R and inductor L in the series. Across the we apply the AC source. Here we take the resistor R that is connected with the inductor. Inductor basically that is the coil and the wire is around it, and now we apply the AC source across both the inductor and resistor. Okay, we know that the resistor that is represented by R and inductor that is represented by L. Okay. Now we apply the voltage, applied voltage V across these both element of the circuit, that is resistor R and inductor L. Okay. One more thing we know that when we apply the AC source across the resistor R and inductor L, current I is passing flow through it. When the current I is passing flow through it, then the voltage is divided in both the element. So we can write that the voltage across the resistor that is represented by VR and voltage across the inductor that is represented by VL. Okay, now we draw the phasor diagram of this circuit. Phasor diagram. If we draw the phasor diagram of this AC circuit, we know that when the current is passing through the resistor R, then the current and voltage R is both in phase. We discussed this there in the last videos that whenever the current is passing through the resistor R, then the voltage and current both are in phase. So here we draw the current I and voltage across the resistor R that is in phase with the current. So it is also in the horizontal line. Okay. Now when the current is passed through the inductor, so when we know that when the in the property of inductor that is always lag the current. So current is lag behind the inductor voltage VL by 90 degree. So here we know that the inductor voltage that is the lead the current by 90 degree. So here we write the voltage VL. That is basically the phasor diagram of these both circuit element resistor R and inductor L. Okay, now we find the applied voltage phasor diagram. First we find the resultant of these two voltage, resultant of these two voltage that is equal to the applied voltage. So we can find the resultant voltage by the formula. Resultant voltage that is basically the applied voltage can be found by square root of the taking the square of root of the voltage across resistor plus voltage across the inductor. We take both square and then take the square root. Okay, according to Ohm law, we know that the voltage V that is equal to IR. एक कमेंट आया है, ये हिंदी में है. Hi to, thank you so much for watching my video. आपने क्या क्वेश्चन किया, क्यों सोल्यूशन कराए? What mean? I don't understand what you want to saying. Okay, according to Ohm law, V is equal to IR. So voltage V is equal to IR is square. So we also take the square. Voltage across the inductor, we know that according to Ohm law V is equal to IR, but in the case of inductor we write the opposition by XL, that is shows the inductive reactance, that is we discussed in the last class, that is equal to Ix square. If we find the resultant applied voltage R square plus XL square, V, if we taking the uh, current I is come out of the square root, it become R square plus L square. Now this quantity, that is the under root R square plus L square, is shows the combined resistance offered to the current flow. Here is the inductor L also offer the resistance to the current flow, and resistor R also offer the resistance to the current flow. So we here find the combined resistance, that is combined resist the flow of the current, that is called the impedance of the circuit. So this is the impedance of the circuit, that is shows the combined resistance offered to the flow of the current. Here we find the impedance, that is equal to under root R square plus L square. So this formula become V is equal to I Z. So we can find the combined resistance of both the element of the circuit by Z is equal to ratio V over I. That is the impedance of the RL series circuit. Okay, we discuss the phasor diagram, then we find the applied voltage V. Now we find the phase angle. Okay, what is the phase angle? Phase angle, that is the, here we draw the first the circuit phasor diagram, that we know that the current in the horizontal line, so voltage across the resistor, that is in phase with the current. So here we draw the voltage across the VL, that is lead the current by 90 degree. So when we find the phasor of the applied voltage, that is shows by the resultant V, and that is make the angle phi with the horizontal line. This angle, phase angle, shows that the current is lagging the applied voltage by phi, by angle phi. So we can find the angle phi if we draw the perpendicular from the diagonal to the horizontal line. If this is VL, this is also become VL. Here we write the formula of the tan phi, that is equal to the perpendicular over base. So that is equal to VL over V R. Okay, now we find the angle phi. We know that VL is equal to, that is equal to I XL. XL, that is shows the inductive reactance. I R, current I both are cancelled. So tan phi is equal to XL over R, or angle phi is equal to tan inverse XL over R. that is the phase angle, we can find by this formula if we know the inductive reactance and resistor R. Okay, if we write the equation of the applied voltage, that is equal to V is equal to V naught sine of omega t, and we know that the current is lag the applied voltage by angle phi. So formula of the current become I is equal to I naught sine of omega t minus phi. Okay हो गया. So this equation shows that this equation shows that inductive current lag behind by angle phi. This is all we discussed today about the RL series AC circuit. क्वेश्चन प्रैक्टिस, कौन से क्वेश्चन की प्रैक्टिस करनी है? I don't understand your question. What were you want to ask? Please clear your question. कौन से क्वेश्चन की प्रैक्टिस चाहिए आपको? Okay, this is we discussed today the RL series AC circuit. We find the impedance, then we find the phase angle. Next we find the power in RL AC circuit. What is the power in RL AC circuit? We discuss that. Our next topic is about the power in RL AC circuit. If you have any question, please ask in the comment section.